Hello everyone. Okay, so the next type of problem is analyze the given beam ABCD by moment distribution method and draw the bending moment diagram. Okay, I can see here AB, BC and CD. AB is having a UDL of 20 kilonewton meter, and at BC there is a point load of 60 kilonewton, and in CD there is a overhang. So CD is a overhang, and at that overhang at D there is 20 kilonewton acting. Okay, so and the I value for AB is 2I, for your BC it is I, and CD it is only I. Okay, so again, as usual, you have to find the same thing. Steps are same. You have to find fixed end moments. You have to find distribution factors, moment distribution table, and finally the final end moments. Okay. Okay. The only different thing about this problem is, see here, this problem, the previous problem is, in the previous problem there was AB and BC. Okay. Same. At B there was roller support, and C also there is roller support. There is simply support. And the extra thing here is only the CD now. So the CD, you have to make all the necessary correction and adjustment at CD. Okay. So now because this is an overhang and at C there is a simply support. So still C will be acting like a simply support only. So what we have to do here is, I've written a note here. You can see this. C is considered as simply support end only. So stiffness of CD is 0. So what we are going to do is we are going to remove the stiffness. The stiffness will exist only if there are the members connecting two joints. So you can see here B and C are connected together, and at B also there is a joint, C also there is a joint. So you can find the stiffness of this member because both are connected at the ends. Whereas in CD span, D is a free end. Okay, C has a simply support, and D there is a free end. So at D there will not exist any stiffness because CD itself is an overhang. So now the stiffness, that is K of CD stiffness, is 0. So this portion is 0. Okay. So C is considered simply support end, and the stiffness of CD is 0. Since the moment in this portion does not depend on other side. So whatever moment is applied here, it is not dependent on this. It is wholly on CD itself because it's an overhang. So whatever extra moments are there, it is carried by C itself only. All right. So first, as usual, find the distribution factor. So first is joint B. So BA, BC. Then at joint C, CB, CD. Okay. Then we know that stiffness in CD is 0. Why? Because D is a free end. It does not have any support. So that way stiffness of this matrix is 0. This portion. Stiffness of this portion is 0. All right. So BA first. BA, the far end is A. So A means it's a fixed support. So fixed support means it is 4 EI by L. Then BC, because C is a simply support. So it is 3 EI by L. Okay, you can see here 4 EI by L. BC. C is the simply support end. So it is 3 EI by L. So it is, add both of this. So it's 1.75. Then 1 divided by 1.75 and 0.75 divided by 1.75 is 0.43. So when you add both of these, it should be, the sum should be equal to 1. Likewise, in C, joint CD, in the joint C, so it connects CB also, CD also. So CB, okay, so this is a joint where it, so joint B, because it's an intermediate support, it will be treated like a fixed support only. So CB is nothing but, so at B, it will be fixed support. So it is 4 EI by L. So CB is 4 EI by L. 4 EI by L, that is 1 EI. And as we have discussed earlier, CD is an overhang. There is no support at D. So that's why stiffness of CD is equal to 0. So stiffness of CD is equal to 0. So when you add both of this, it is 1 over EI. So 1 by 1 is 1 again. And this is 0. Okay. All right. Next is the final moments. Okay. Next is the final moments. Okay, so in final moments, it is A, B, C, and D. You have to draw the complete beam only and draw the table. So A, B, C, and D. So first is at B. So it connects, then write the next row, that is AB, BA, BC, CB, CD, as well as DC. Then distribution factor. So for AB it is 0. Next for BA we have already calculated, it is 0.57, BC is 0.43, and CB is 1. So right here 1. And of course CD is 0. So this is 0. And of course at D it is 0. If you write also it is okay. If you don't write also it's okay. This portion. Okay. All right. Next is fixed end moments. We have already calculated all the fixed end moments here. AB, BA, BC, CB, and CD also. So FCD is equal to minus force into its perpendicular distance. At this portion, FCD is force into its perpendicular distance. Okay. All right. Now, once you write this, so this is fixed end moments we have written here. All right. Next is our main intention is to balance the simply support. Now, because it is a fixed simply support, the first thing is what you have to remember is in distribution factor, you have to take it the stiffness matrix as stiffness as 3EI by L. That is the first thing. And the second important thing is you have to balance the moments. You have to balance the moments. So when you're balancing the moments, just check this out. So here it is 30. Okay, you have to balance joint C because joint C is a simply support end. Because C is simply support end, you have to balance this. So it is 30 minus 40. 30 minus 40 is minus 10. So minus 10, you have to change the signs here. So minus 10 becomes plus 10 here. So plus 10 into 1 is 10. Plus 10 into 0 is 0 here. So it is this portion is 10 and this portion it is 0. Okay, important thing, whenever you're balancing the moments, you have to always first add those. If you get a negative answer, then change the sign and then write this answer here. Change the sign, multiply with the distribution factor, and then write the answer. So now, right now it is 30 minus 40, so which is minus 10. So minus 10, change the answer. So it becomes plus 10. So plus 10 into 1. So it becomes 10 here. So I've written here. And here 10 into 0 is 0 only. All right. Okay. So now the CB, from the CB, now the next adjacent joint is a continuous support. So you have to carry over. So once you balance, after balancing, you have to carry over the moment, given moment. So this is now 10. So the adjacent joint happens to be uh, BC. So this is CB. Half of this gets transferred here because it is an intermediate joint and it will be treated like a fixed support. So half of 10 is 5. So plus 10 divided by 2. So it's plus 5. Okay, so this is a carryover moment. Now we have to make all the necessary adjustments at this joint only. Okay, now again, the check you can see here at D, the moment is 0 only. There are no fixed end moments, obviously. So this is 0. All right. So once you transfer this, next is 106.67. Now you have to do all the necessary calculation at joint D. So it is 106.67 minus 30 plus 5. Okay. 106.67. So at B, you have to consider all of these. 106.67 minus 30 plus 5. So when you add this, it will be 81.67. So answer is positive. So 81.67, you have to change the sign. Change the sign. You have to change the sign and then, so plus becomes minus. So it is minus, minus. Okay. So minus, minus. So 81.67 into 0.57 is 46.55. Similarly, 81.67 into 0.43 is minus 31.11. So this is again balanced now. So balancing carryover moment, then again balancing. So this is all balanced now. Once this is balanced, now you can see here, you cannot transfer this 35.11 here because if you try to do this end joint C is a simply support. We have already balanced here in the beginning only. Okay, now you can see here, this is minus 40 and this is plus 40. So this joint is balanced now, equal and opposite. They are balanced. Again, you cannot transfer this carryover moment here. So what you can do here is, next the only joint left here is from BA it gets transferred to AB because A is a fixed support. So from BA it gets transferred. So minus 46.55 into uh, zero point 0.5 or divide by 2. Half of this gets carried over here. So minus, so it becomes minus 23.27. Okay, half of this gets carried over here. It's minus 23. So once this it gets carried over, there's nothing balancing again at joint B or C. So this is the time where you have to stop. Okay, so finally in the final moments add all of these. So this is minus 106.67 minus 23.27, so it's minus 29.94. That's at joint A, that is in member AB. Next, similarly at B, add both of these complete in the column. Okay, so it is one way, it is 60.12. In this portion it is minus 30 plus 5 minus 35. Okay, so this is again it's minus 60.11, and here it is plus 40 minus 40, and it is 0. Okay, so now the check is at B you're getting joint which are equal and opposite. Magnitude is same 60.12, but they're opposite in direction. So it is, this is plus, this is minus. Likewise here also it is plus and this is minus. So whatever done is right. Okay, next is you have to just draw the bending moment diagram. So as usual, draw the bending moment diagram. Of course for this I have not done because it's same like the previous problem. So first draw the free bending moment, that is UDL here. Then there is a point load here. All right, and this load, it comes below here like this. 20 into 2. Okay, then finally join all of these and mark all this at A, B and C. Mark all the moments here, A, B and C. Okay, final moments A, B and C. All right, like this you have to solve the moment distribution method for simply support beam with a overhang as such. Similarly, you can see here also again in this portion, analyze the continuous beam by moment distribution method and draw bending moment diagram. Assume that EI is constant throughout. Okay, you can see here A, B, B, C, C, D. Okay, it is same like the previous problem. Okay, but what happens here is at D. Okay, at see here, for example, A is a fixed support, B is intermediate support, fixed support, C also intermediate support, fixed support. But the only thing here is at D, you should treat this like a simply support. Okay, so simply support. So ABBC 4EI, BC CB is 4EI, CD would be 3EI by L, whereas DC is 4EI by L. Okay, again, once you find out this, next, whatever moment you're getting here, balance it here. Okay, change this, what you have done here. Here we have taken it as, we have taken C as the support wherein you have to balance the simply support. But here what you do, you have to balance the support D. Once you balance support D, go on changing, go on carry over movement to C. Okay, then go on carrying on the iterations as such, what you've done before. And same thing again, balancing, carry over, balancing and carry over. Okay, after that stop it. Once you balance it and carry over it and stop it. So once you stop it, sum up all the answers, so you'll get the final end moments. So these are the final end moments values. You can just cross check, solve this by yourself, cross check and check if whatever done is right or wrong. So the only check in the beams is at the given joint. So if it is B and BC, should be equal and opposite. Likewise at C, so CB and CD should be equal and opposite. Only then whatever done is right. Okay. All right. Okay. So with this, we'll conclude the session. That's all for today. Thank you.